Hi, in this video, I'd like to introduce the concept of percents, how to convert percent to and from decimal or fraction, and how to solve percent problems using the percent formulas. A percent represents some part of a whole. That's what a percent does. Now, you may recall that your math teachers probably also told you that fractions also represent some part of a whole. Percent is actually a special kind of fractions. Imagine that we have a cake. That's one whole. Now we can take a part of it. We can take half of it. That's 1 out of 2, 1 over 2 in fraction form. Or we can take 1/4 of it. That's 1 over 4 in fraction form. Or 1/5, 1 over 5 in fraction form. These are all fractions, and the fractions can be divided into decimals. 1/2 equals 0.5. 1/4 equals 0.25. 1/5 equals 0.2. Fractions and decimals are equivalent. But note that to do this dividing, we have to divide by a different denominator each time. So people think, what if we use a bigger denominator? Then the whole is divided by smaller pieces, and maybe we don't have to change denominators all the time. One particular number they try is denominator 100, and it turns out that when they choose the denominator of 100, many things become easy and convenient. And that's why we're doing it a lot these days. And preview, that's the percent. All right, we take a cake and we subdivide it into 100 small pieces. Let's try to make the same fractions on these subdivisions. If we take half of 100 small pieces, we get 50 out of 100. A quarter of them, 25 out of 100. 1/5 of them, 20 out of 100. You see the similarities between the decimals on top and the fractions out of 100 in the bottom? It's even more obvious if I put extra zeros at the end of decimals. You see the similarities now, yeah? When we take fractions per 100, the numerator looks very similar to the decimal value. That's why we use percent. We write the fractions per 100 or over 100 as percent. And the reason why we do it is because it has a direct relationship with the decimal value, and it makes calculations easy. That brings us to the definition of percent. The fraction of part over whole, if we write it in form of some p over 100, we call it p percent. For example, 1 over 2 equals 0.5, which is the same as 50 over 100, and therefore is 50%. Another example, 1 over 4 equals 0.25, which is 25 out of 100, 25%. 1/5 equals 0.2, which equals 20 out of 100, or 20%. So some of the common percentages that you probably encounter often include 100% for the whole thing, 50% for half, 20% for a quarter or 1/4, 10% for 1/10, 20% for 1/5. And there are some approximations. For example, 33% is approximately 1/3, and then 2/3 is approximately 67%. That's a general idea of percent. Now let's talk about converting percent to and from other forms. First, let's look at converting from decimal to percent. We already know that 0.25 is equal to 25%. Notice that they both represent the same quantity, the same fraction, the same 1/4 of a whole. They just look different. We look at the two numbers, we see that they both share the same numerals. They're both 2, 5. But they're different in where the decimal point is. In the decimal 0.25, the decimal point is before the 25. In the percent form, 25%, the decimal point is invisible, but it's right here after the 25. If we line up the numbers, they look like this. The decimal point on the number 0.25 is here. And it looks like in order to arrive at where the decimal is with 25%, it had to move 2 places to the right. That leads us to the rule of converting from decimal to percent. We're going to do exactly that when we convert a decimal number to a percent. To convert from decimal to percent, move the decimal point to the right by 2 places and put the percentage symbol in. Now note that when we do that, the number in percent form looks bigger. It appears bigger than the number in decimal form. The number 25 in 25% appears larger than 0.25. Okay, by the way, that's just the appearance, all right? 25% is equal to 0.25. It's just that the number 25 appears to be bigger. Let's now practice this rule on these 3 decimals. 0.3 convert to percent. We take this decimal point here and move it 2 places to the right. The empty space here, we fill in with zeros, and that makes it 30. And then we put the percent symbol in. The answer is 30%. Next, convert to percent 0.923. Take the decimal point, move it 2 places to the right. We arrive at 92.3, and we'll put the percent symbol in. The answer is 92.3%. Bottom example, convert to percent. 1, just 1. There isn't any decimal point, but all whole numbers have an invisible decimal point right here. 1 is the same as 1 point. And now I move it 2 places to the right. I fill in the blanks with zeros. I put the percent symbol in, and the answer is 100%. So far, so good. Now let's do this one. Convert to percent. 2, just the number 2. Okay, it's a whole number, but there's an invisible decimal point here. Move it 2 places to the right. Fill in the blanks with 0, put the percent symbol in. The answer is 200%. Wait, is 200% even possible? Many of you may have been told that we cannot have more than 100%. And 200% is more than 100%, so is that possible? Oh yeah, it's totally possible. You totally can have more than 100%. There's no rule that says you cannot have more than 100%. That's a myth. Let me show you an example. Suppose mom lays out a bunch of Oreo cookies. And she says each kid can only have 2. So the quota is 2 cookies. But me, I take 4 of them. I take double. I take 2 times the quota. That means I take 2 times, and 2 is 2.00, which then after I move the decimal point, I get 200%. I take 200% of my quota. I probably get like punished for it, but I did it. It's doable. 200% exists. So yeah, percentages can be higher than 100%. Here are some real-life examples of percentages higher than 100%. There are countries that are trying to limit the imports of luxury items because a lot of countries are protectionist. To prevent people from importing luxury items, they want to make sure those imports get very expensive. So they impose a really high cost on those imports. Now, these things are called by different names. They call it a tax, they call it duties, excise, tariffs, whatever. But at the end of the day, it's money that you have to pay the government to import luxury goods. And there are many countries where the percent you have to pay is higher than 100% of the value of the item. In Indonesia, if you import a luxury motorcycle, they may tax you up to 125% of the value of the motorcycle. If the motorcycle costs $10,000, you may have to pay up to $12,500 in duties, plus the cost of the motorcycle. So altogether, you end up paying more than $20,000 for a $10,000 car, motorcycle. In China, they treat all cars as luxury items, and they may tax you up to 200%. In Tunisia, a diesel-fueled large engine car, so we're looking at something like a diesel Mercedes-Benz, you may have to pay tax up to 360% of the value of that car. So yeah, if more than 100% of something is available, then you can have percentages that go over 100%. All right, up to this point, you know how to convert from decimal to percent, and you found out that percents greater than 100% are totally possible. Now let's convert the other direction from percent to decimal. Since it is the conversion in the opposite direction of what we already know, the method is also the opposite direction or reverse direction of what we did. We've seen this before. 25% equals 0.25. Last time we went from 0.25 to 25%. Now we'll go from 25% to 0.25. Which way did the decimal go in this example? In the number 25%, the decimal point is invisible here. In 0.25, the decimal point is to the left of the 2. So how did it get there? It moved 2 places to the left. There we go. That's the conversion method. To convert percent to decimal, move the decimal point 2 places to the left and drop the percent symbol. Now, it may be hard to remember which way to move the decimal point. Is it to the left or is it to the right? Because sometimes we move to the right when we convert from decimal to percent. And then when we convert from percent to decimal, we move to the left. So which one is it? How do you remember it? So here's the trick. Just remember that when written in decimal form, the number appears smaller than in percent form. And vice versa. In percent form, the number appears larger than in decimal form. The number 0.25 appears smaller than 25. So if you move the decimal point in the wrong direction, you get a number, an answer that doesn't make sense. Then just erase it and do it again, move in the other direction. Let's do an example. Convert 80% to decimal. There's an invisible decimal point here. So we move it 2 places to the left and we end up here. We drop the percent symbol. The answer is 0.80. Or many people may write it with a 0 in front, 0.80. Next example, convert 0.1% to decimal. Yes, a percent can be decimal by itself too. In this case, 0.1% means 1/10 of a percent. The decimal point's right here. Let's just move it to the left 2 places, fill in with zeros. The answer is 0.001. All right, that's how you convert from percent to decimal. We already know how to convert from decimal to percent. Here's a summary. Instead of memorizing the method, I suggest you just remember the example. Maybe think of it as a prototype or a template. 25% equals 0.25. Once you think of that, it's easier to recall the method, like which way the decimal point moves. Now let's talk about how to convert to and from fractions. Let's take the same example of 25%. again, is equal to 1 out of 4. Remember this slide? 1 out of 4 is divided. 1 divided by 4 equals 0.25 when we related that to the 25 out of 100 fractions. So that's the key. Just divide the fraction out. Use a calculator if you have to. And there's your decimal that you can convert to percent. So that's the first step. Divide the fraction. Let's divide the fraction 1 over 4. 1 divided by 4 equals 0.25. Like I said, use a calculator if you need to. On the other hand, if your teacher or professor doesn't allow calculators, then you need to review long division with decimals. But anyway, whether or not you have a calculator, you divide 1 divided by 4, and you end up with a decimal, 0.25. You convert it to percent because we know how to do that, right? Just move the decimal point. The answer, 25%. Very good. That's how we convert from fraction to percent. Now let's talk about converting the other direction, going from percent to fraction. Let's take 25% again. 25% equals 1/4. How would one go about making that conversion? Let's take a look at the same slide we've seen before. The 25% came from the fraction 25 over 100. Well, there we go. 25 over 100 is a fraction. So we're done. There we go. That's our method. Because percent symbol represents per 100, we rewrite the percent symbol as a fraction out of 100. 25% equals 25 over 100. And we're actually done. We have our fraction. But often your teacher or professor would require you to simplify completely. So, sure, let's do that. 25 over 100 simplifies by 5 to becomes 5 over 20. And now we simplify by 5 again, and we have 1 over 4. Answer 1 over 4. Let's do some more examples. 18%. This equals 18 over 100. Simplify by 2, I get 9 over 50. I'm done. Next example, 630%. 630 over 100. Simplify by 10, 63 over 10. Done. By the way, do you know how I know I'm done so quickly without checking for more simplifications? Because when we simplify a fraction of something over 100, the 100 in the denominator is only divisible by 2, by 5, or by 10. So we only need to check 2, 5, and 10. We don't need to check for 3 or 7 or anything else. So in this case, I arrive at 63. I know it's not divisible by 2 because it's an odd number. I know it's not divisible by 5 because numbers are divisible by 5 always end in 5 or 0. This one ends in a 3, not divisible by 5. Numbers are divisible by 10 always end with a 0. This one doesn't end with 0, so I know I'm done. Yeah, I don't need to check for 3 or 9 or 6 or any of those other numbers. One more example. Convert 7.2% to a fraction. First, I write 7.2 over 100. Now I have a problem because I have a number with decimals in the numerator. That makes it an improper fraction, so that's no good. I need to fix that. I need to move that decimal point. So there are two ways to think of it. You can think of it as multiplying both the numerator and the denominator by 10. Then I get 7.2 times 10 equals 72. 100 times 10 equals 1,000. Now I have a proper fraction. I can simplify now. There's another way to think about it is if I have 7.2 over 100 like this, and I want to move the decimal point here over here to make it 72, then down in the denominator, there's a divisible decimal point here. I also need to move that by one place. okay, because everything I do in the numerator, I not need to do the same thing in the denominator to make it nice and even, right? So I moved this decimal by one place, I fill in with a 0, and that also gets me to 72 over 1,000. All right, I'm at 72 over 1,000. I'm ready to simplify. 72 is an even number, so I can simplify by 2. I get 36 over 500. I simplify by 2 again. I get 18 over 250. And I divide by 2 one more time. It's 9 over 125. Now I'm done. Final answer, 9 over 125. All right, here's a summary on converting between percent and fraction. Let's now move on to the percent formulas. This was our definition of percent. The part divided by the whole equals a number, usually a decimal, and then converted to a percent. 1 divided by 5 equals 0.2, which equals 20% after I move the decimal point 2 places to the right, yeah? Let's remove that diagram. I go from 0.2 to 20 by moving the decimal point 2 places. But moving the decimal point 2 places to the right is also the same as multiplying by 100. 0.2 times 100 is equal to 20. And then I write in the percent symbol. Guess what? That means moving decimal point 2 places and putting the percent symbol in is the same as multiplying by 100%, right? Multiply by 100, that's equivalent to moving 2 places and put in the percent symbol. Therefore, there are 2 ways to think of the percent formula. One way is percent equals part divided by whole times 100%. And a lot of teachers and professors teach it this way. Another way to think of it is percent equals part divided by whole. That gets you some kind of decimal, and then you convert to percent. That's the formula. The 2 formulas are the same formula, just written differently. Now let's apply it to solve some problems. Example, 3 out of 4 is what percent? Well, let's apply the formula. We have the number 3 and the number 4. Which one is the part and which one is the whole? The way the question is phrased, it sounds like we have 4 of something, and then we take 3 of them. That means the fraction is 3 over 4. Part over whole equals 3 over 4. Plug in the formula. 3 over 4 equals 0.75 times 100% equals 75%. Or you can do it differently as 3 over 4 equals 0.75, and then you move the decimal point 2 places to the right, equals 75%. So far, so good. Next example. 18 people started a marathon. 3 gave up, and the rest finished. What percent finished the marathon? What is the part and what is the whole? The whole is easy. It's the 18 who started a marathon. But the part, the question asks for the percent that finished the marathon. That part is 15 people, not 18, not 3. The 3 gave up. That leaves the 15 that finished. Therefore, part over whole equals 15 over 18 equals 0.8333 repeating. Part over whole times 100% equals 0.8333 repeating times 100%, and that equals 83.3 repeating percent. So I'm just gonna round up and stop at 83.3. Final answer. All you get? By the way, if you have any question about this, write in the comments section below. Here's when to use this formula. The formula has percent on one side and the part and the whole on the other side. So it's telling you to use this formula when you know the part and the whole and you want to compute the percent. All nice and good. But what if the given information is different? You're not given the part and the whole, or the question asks for something else. Well, in that case, we use algebra to move the formula around. And after we do that, these are all the percent formulas. They're just one formula, but things are moved around differently. If you're good with algebra, you can just stick with one of them and use that one to figure out all the rest of them. But in this video, I assume you don't want to do the algebra and you want all the three formulas, so I'm giving you all three formulas. Which formula to use depends on what you're given and what the question asks you for. Look at this first formula. On the right, the formula has the part and the whole. On the left, it says percent. That means the question asks for the percent. Therefore, we use this formula when we're given the part and the whole, and we're asked for the percent. Second formula. On the right, the formula has the part and the percent. On the left, it says whole. That means the question asks for the whole. Use this formula when we're given the part and the percent, and we're asked for the whole. Third formula. On the right, the percent and the whole. On the left, it says part. That means the question asks for the part, and we're given the percent and the whole. So if that's the situation, use this formula. Let's do some examples. A professor announces that 15% of students received an A in the class. If the class has 40 students, how many received an A? First question we ask ourselves, what are we given and what are we asked for? Let's draw a diagram. By the way, always try to draw some diagram when working with a math problem. We're all visual to some degree, so a diagram always helps. We're told there's the class, and some got A's. And the people that got A's are a part of the class. So the diagram looks like this. We're told the percent that got A's was 15%. We're also told the class has 40 students. So the diagram tells us that the class is the whole, the people with A's are the part, and the percent is 15%. And it asks how many people got A's. The people that got A's are the part of the whole. It's a small part, and that means we're asked for the part. And we know the whole of 40 students, and we know the percent is 15%. And therefore, we're going to use the formula with the whole and the percent on the right, which is this formula. Part equals percent in decimal times the whole. Apply that. Whole equals 40, percent equals 15%, which equals 0.15, which means the part equals 0.15 times 40. That equals 6. Answer, 6 students received an A. Next example. A high school announces that 6 of the graduating class, or 12.5%, have been offered admission to UCLA. How many students are in the graduating class? Again, we ask ourselves, what are we given and what are we asked for? Draw a diagram. There's a graduating class. Some got in UCLA. And we're told that percent is 12.5%. And we're also told the number getting into UCLA is 6 people. And we don't know the size of the graduating class. In fact, that's what the question asks for. That means we know the part, we know the percent, and we're asked for the whole. We need to use a formula with part and percent on the right and the whole on the left. This formula, whole equals part divided by percent in decimal form. Plug in the numbers. Whole equals part is 6 divided by percent is 12.5%. In decimal form, 12.5% equals 0.125. Divide out, we get 48. Answer, there are 48 students in the graduating class. Next example, 12% of what equals 4? Treat this question like all percent questions. Ask yourselves, what are we given and what are we asked for? Draw another diagram. There's some whole, there's some part, there's some percent. The percent is 12%, so we know that. What's the whole and what's the part? We're told that 12% is 12% of this word, what. So that means the whole is the what, meaning the question asks for the whole. And we're told that 12% equals 4, meaning the part equals 4. We know the part in the percent. The question asks for the whole. Use this formula. It has the part in percent on the right. Whole equals part divided by percent in decimal. Plug in the numbers. Whole equals 4 divided by 12%. 12% in decimal form is 0.12. Divide it out, we get 33.333 repeating, which we round to 33.3. Final answer. Are we all good? That's everything. Let's now summarize. Here are the conversion formulas. To convert from decimal to percent and vice versa, move the decimal point. Remember the prototype 0.25 equals 25%. It will help you recall which way to move the decimal point. The number in decimal form appears to be smaller than the number in percent form. To convert from fraction to percent, divide out the fraction and convert the decimal to percent. To convert from percent to fraction, write the percent as fraction over 100. If there's a decimal point in the numerator, then move both numerator and denominator as needed to make the decimal point go away. And then simplify. And then here are the percent formulas. Depends on what's given and what's being asked for. Choose the appropriate formula. That's it. That's everything about percent. I will add another video about percent changes. So make sure you subscribe for more contents. Hope this helped. Any questions or comments, write in the comment section below. Thanks for watching. Bye.